Thank you for coming to this session. This is called Deep Dive into LWC Best Practices. We are your hosts for this event. We have Dale Bustad and Nolan Lawson. We did not intentionally color coordinate. Oops, sorry about that. But kind of just ended up this way.
Diversity in shoes. That's really it up here.
Yeah. So he's the one with different colored shoes, not this light brown. Forward-looking statement. So you've probably seen this slide a bazillion times today, but once again, Salesforce is a publicly traded company. Please make all your decisions based on the features that are currently generally available and not about the future-facing things that we may be talking about in this presentation. And also, there is a survey going on, so please feel free to copy this QR code and to do this survey, and you may or may not win a coffee from this. For those whose energy is flagging at the end of the day and needs a coffee, maybe this is your chance. All right, so once again, we are your hosts, Dale and Nolan, and we are both on the LWC team, or LWC framework team, that builds Lightning Web Components. So the agenda for this, we are going to be talking about these three main sections right here. We're going to start off with just a quick introduction to what is LWC. Hopefully, lots of folks already know what LWC is. If you don't, that's fine. You're welcome. We will get you up to speed. Then we will talk about best practices, just some common gotchas, some little-known tips and tricks that people might not be so familiar with. And then finally, we're going to end with some new and upcoming features in LWC that either have just recently shipped or we're planning on shipping soon, and that might actually change the way that you author your LWC components. So first off, what is LWC? So LWC, or Lightning Web Components, this is the motto that has been emblazoned on our open source lwc.dev site for some time, since the inception of LWC some 5-6 years ago, something like that. Which is, it is a blazing fast, enterprise-grade web components foundation. And I think we've done a pretty good job of hewing to that over the years, right? We kind of earned it. And so this talk, we're going to be talking about kind of the fundamentals of the framework, fundamentals of LWC, which in a sense you can kind of think of as like you can compare it to React or to Angular or to Vue or these kinds of JavaScript frameworks. Like we are a JavaScript framework, and we are the JavaScript framework that is kind of the primary lens you have into building front-end experiences for Salesforce.
Yep.
OK, so starting off with best practices. I'm going to go over a few common gotchas and then also talk about some little-known features and some useful tools that might help you to avoid some of these gotchas and some of these anti-patterns that we're going to talk about. So here's one. This is a gotcha that I have seen several times in many components. And this is the do not do slide, by the way. So if you're taking a photo of this, like just wait for the do slide afterwards. So here is the anti-pattern. So what often happens is when you're writing an LWC component, you want to do some kind of setup logic, and then later on you want to do some kind of teardown logic, right? So for example, you might set up some global event listeners, or you might subscribe to an event bus or a pub sub or something like that, and then you want to undo that logic later. And the mistake that I see a lot of people make is that they put the setup logic inside of their constructor, and then they put the teardown logic in their disconnected callback. What you want to do instead is you want to do the setup logic in the connected callback and the teardown logic in the disconnected callback. And the reason for this is fairly simple. It's that the constructor is called exactly once when the component is created, right? Whereas the connected callback and disconnected callback, those might fire multiple times. One common scenario where this happens is if you have a list of components and say that list is being reordered or sorted, right? Under the hood, the framework might be pulling out the component and putting it back into the DOM. And by doing that, that fires disconnected callback and then connected callback. So what you should remember is that if you're going to do this kind of setup teardown, just make sure you put the mirror logic in connected callback and disconnected callback.
All right. Are we going to hand it back and forth? All right. So next up, we have template refs. Starting with what you shouldn't do. This is actually pretty common, and it would be a pattern that you would borrow from other web development that you might do outside of the Salesforce ecosystem. So it's kind of an understandable starting place. But what you see here is you're using the query selector method of the template. There are corollaries to this as well. It's not just this one method. It's just the example we're using here. And then you're getting a handle on some div inside of your template, right? And you might want to be doing different things with that. Maybe you're interacting with DOM APIs for that element. Maybe you're setting event listeners on that element. Maybe you're interacting with a child component and invoking methods on that component, something like that. So there are a lot of reasons why you might want to do this. But it is a little bit problematic. And one of the reasons may be apparent to you really just here on the slide, and that is you probably have more than one div in your template. So as your template changes, as you reorder this, what you're actually selecting here can change. And it's just going to be kind of an implicit change without it really being super obvious what you're actually getting a handle on here. And so instead of that, we recommend using the LWC ref directive. You see at the top, we have that same div, and the directive is inserted. It's the LWC:ref, and then you give that div a name. Call it myDiv. And then you can actually reference that in your JavaScript later on. So in rendered callback, after rendering has occurred and the DOM is all present and operating in the browser window, you can reference that div element using this .refs and using the myDiv name that was provided earlier. Beyond just kind of having some security around knowing what you're actually working with, what you're operating on, there are some performance implications here where if every time in the previous slide where your, the back is not actually working. Oh, there we go. Where you're querying the DOM, that's going to potentially be happening a lot. Whereas under the hood, using the LWC ref directive, the framework can do a lot of that work for you and just be really efficient. So there are performance implications here. There's sort of like referential integrity questions here that are answered by using this pattern. And then there are other reasons that are a little bit more opaque we're not going to go into right now. But generally speaking, this would be the tool that we recommend you reach for.
It's also just a lot less typing. That's why I like it. I'm lazy. Next, I want to talk about a really useful tool that not a lot of folks are familiar with, actually, we realize. And that's called LWC Code Mod. So LWC Code Mod is an open source command line tool that you can use. And what it does, effectively, is it will run transformations on your code base in order to do useful things for you. So the way that you run it is here I'm using npx, which is just a way of running code from npm. You can also use npm install if you'd like to. And when you run this, you can point it at your code base. In this case, I'm pointing it at forceapp main default LWC. And it will operate on all the LWC components that you have in that directory. We offer a few useful code mods. We have synthetic to native, which moves your components from synthetic shadow to native shadow. And we will talk a little bit later about what exactly that means. We have shadow DOM to light DOM. And we also have HTML template cleanup, which just fixes some minor errors that might be in your HTML files. So this is a very useful tool that a lot of people haven't heard of.
And I'll just add, we plan to put more code mods in here. So this is something that you can watch. You can find the project on GitHub. And if you're interested in the sort of like automatic transformations that we might be providing to you, that would be a good place to watch. Thanks. All right, so next up, we have an anti-pattern. Up at the top, this is in your CSS file for your LWC. And we have a selector that you're using, and it is this LWC-BSF numbers and letters. You've probably seen this if you work with LWCs regularly. It's going to show up in the DOM. It's not something that you're writing necessarily, and actually the anti-pattern here is that you would be inserting into your code. And the reason for that is this particular class name is generated by the framework. It generates this for a number of reasons. It's used for a number of things under the hood, but it's just sort of like an internal implementation detail of the LWC framework. It's not intended for consumption by components directly. And so one thing we are seeing is people will look in the DOM as they're debugging their component, and they see a class that's so handily attached to their component in the DOM. They're like, oh, I can add a rule for that so that I can make the color red. And at first blush, that may seem like a reasonable thing to do. But the way we generate these or these class names, rather, it's not stable. It may change from LWC version to LWC version. So when we roll out to the next release, all of a sudden your components might break because you're relying on some internal detail that you're really not intended to. And there are other reasons not to do this as well. First, top of mind for me is it's not very explicit. This is not a very descriptive CSS class name. So if somebody else is coming along and reading the code later, they're not really going to understand why you did what you did because it's not very descriptive. So instead of doing that, give it a name. Choose a name in your CSS. You can call it my class, ideally something more descriptive than that that relates to the purpose of that class. And then reference that name in the DOM, in your template. So here we have my class in CSS, and then in the div, we have that referenced my class. And so anything inside of that div will be color red. So yeah, again, we recommend using your own names, descriptive names, rather than these implicit names that are sort of generated internally.
OK, so we are out of the rogues gallery of anti-patterns that you should not be doing. And we're moving on to the next section where we talk about new and upcoming features in LWC, the framework. So we're going to talk about three main things. We're going to talk about component-level API versioning, native shadow DOM, and then finally we'll end with server-side rendering, or SSR for short. So first off, component-level API versioning. So this is something that we launched. It's already GA as of last year. And it's kind of an under the hood sort of implementation detail of the framework, but I think it's something worthwhile to be aware of. So I want to preface everything I'm about to say with emphasizing that your existing components will not break. Okay? We actually work really, really, really hard not to break your components. It's top of mind for us all the time. We really value backwards compatibility. We don't want to make it so that the components that you all spent so much time writing and that you ship to your customers, we don't want those to break from Salesforce release to Salesforce release. We spend a lot of time on backwards compatibility. However, this kind of inherently limits our ability to move the framework forward sometimes, because one person's bug fix is another person's breaking change. And so component-level API versioning is an attempt to kind of get the best of both worlds and to move forward more quickly while also not breaking your existing components. So the punchline is essentially that you might need to bump the API version in your JS Meta XML file in order to get new features, bug fixes, and speed improvements.
And I would just add, when you bump, you may encounter some breaking changes. So it's kind of a package deal. If you want the new thing, you have to deal with the new reality.
And so what does this bumping look like? Well, you might already be familiar with this API version in this JS Meta XML file. Usually right there and generated when you're using the SFCLI. All you need to do is go in there and just periodically bump this to the latest API version that corresponds to the latest Salesforce release. So in this case, I'm on version 58. You can bump that to, I think the latest is 60, right?
I think that's right.
And that will ensure that you get the latest and greatest features, bug fixes, speed improvements from LWC. But as Dale mentioned, you might need to go and test your components to make sure that they're still working correctly as you expect. And if you don't have time to do it right now, you can just leave it on an older version, and it will continue to work as it did in previous Salesforce releases. So this is a really, really simple example, kind of a silly, trivial example, just to kind of illustrate what we're doing exactly with API versioning. So here's an example of something that we shipped back in winter 24. So prior to winter 24, if you had this kind of syntax error in your HTML right here. So I've got a pretty simple syntax error. I've got a double ending template tag, right? In previous versions, that's treated as a warning. We just let you know, hey, you're doing something kind of weird here. We're not sure what's going on, but we're just going to call it kosher, and we're going to say that it's OK. We're going to proceed with something, right? Whereas in winter 24, we decided to turn this into an error so that you can be sure that your components are not doing something odd. You haven't put in an extra tag, and it ends up rendering something that you didn't expect it to render. We want to surface that to you earlier and say, hey, you should probably take a look at this, right? But to avoid breaking existing components, if you are on an older API version, then it will continue to be a warning. And just so you know, you can use LWC code mod to actually fix up exactly this syntax error that I just mentioned. So if you're like me and you're kind of lazy and you don't want to go and manually fix all of your components, you can just run this tool, and it will do it for you, and you don't have to worry about it. Here's a kind of meatier example of what we're doing with API versioning. So this is native object rest spread. Okay, that's a lot of words. What does that mean exactly? Well, that is a JavaScript feature that refers to this ... syntax that you see right here. And all this is doing is it's essentially doing a shallow copy of this bar object into the foo object. This is just standard behavior available in more recent browsers. Because it is not available, though, in older browsers, including Internet Explorer 11, historically what we did when you would write this ... is we would use something called a Babel polyfill to turn it into all the code you see on the left. And that was compatible across all the browsers that we needed to support. Internet Explorer 11, IE 11, is no longer supported on Salesforce Lightning, nor are all the other legacy browsers that did not support this feature. So in Spring 24, we changed it so that your ... is just a ... instead of all this junk you see on the left, which ends up being quite a bit smaller. Yes, right. It's like 98% smaller in this case, which is a perf win, so that's a performance improvement. But we discovered during testing that there are subtle differences between the way the code on the left runs versus the way the code on the right runs. It's very unlikely you're going to run into this, but like I said, like we take backwards compatibility really, really, really seriously. We really don't want to break your components, and so that's why we put this behind API versioning. All right, so what all are we doing with API versioning? Well, there's actually a ton of stuff. We've been rolling this out over the past few releases. We intend to continue rolling out additional improvements over the next few releases. I would bore you to tears if I went through all the details of what all this stuff is. You can find this online in our release notes in order to get into the fine-grained, nitty-gritty details if you really like. All you need to know is that what we were trying to do is we were trying to make your LWC components faster and more standards compliant and fixing some long-standing bugs. And that's effectively what we're trying to do as we roll out these API versioning changes release to release. And if you want to learn more, there is a blog post that goes into excruciating detail on this. And this will be linked at the end of the slides with a QR code, so you don't have to take a photo of this if you don't want to. OK, the next feature that recently launched in LWC that I want to talk about is native Shadow DOM. So native Shadow DOM is beta as of last month, as of February 24. And it's a new feature that you can opt into that gives you a different way of using Shadow DOM than what has been historically available to LWC components. So first off, just a quick refresher on what Shadow DOM is. Shadow DOM is effectively the encapsulation boundary for your components. And it's been there since the inception of LWC, and it kind of looks like this, right? Like you might have a component called custom, and inside of that will have a shadow root, which then contains your hello world, whatever you want to put in your component. And this encapsulation boundary just avoids like you stepping on other components' shoes and accidentally mixing variables together. And it also serves as the encapsulation boundary that is used by Locker and Lightning Web Security as a security boundary. So it's kind of fundamental to the framework. Now, historically, what LWC has used under the hood is something called synthetic Shadow DOM, which is effectively a polyfill or a JavaScript implementation of the native browser Shadow DOM standard. And the main reason that this was done was, once again, for compatibility with legacy browsers that did not support the native browser standard, such as IE 11, which is, again, no longer supported. As such, it's a partial polyfill, which what that means is that it doesn't perfectly mimic every single thing that the native functionality does, right? It has a lot of little tiny differences. One big difference, for example, is that the synthetic version allows for CSS leakage. So any global CSS just naturally leaks into components, which is not the way that standard Shadow DOM works in browsers. Additionally, it's missing a lot of features, notably features in CSS, such as part and slotted. And also, it does not support server-side rendering or SSR.
Which we'll be talking about in a minute.
Yes, and we will talk about SSR later, yeah. Also, we just found in our testing that it's a little bit slower than native, which kind of makes sense because it's a JavaScript implementation of something the browser should be doing, the browser is doing and implemented in presumably C, C++. So it just tends to be a little bit slower. So what we are putting in beta now is native Shadow DOM, which is just directly giving you the browser's actual built-in Shadow DOM support, supported by all the modern browsers. And on top of that, it gives you a lot of things that just happen to be supported in the native browser Shadow DOM that aren't supported by synthetic Shadow DOM, the partial polyfill, including things like CSS part and slotted, which I'll show an example of later, and also our implementation of server-side rendering. Also, in native Shadow DOM, you don't need to type LWC DOM manual anymore. Yeah. OK, you get it. You get it. All right.
Move up to the front. I need your energy.
Less typing, right? Don't we all like less typing? OK. So how do you migrate to native Shadow DOM? Well, it's pretty simple. You just add this static shadow support mode equals native to your components, and that instructs the framework to render the component in native Shadow DOM mode. Or, in a recurring theme, you can use LWC code mod to do the same thing, and you can even point it at your entire directory of components, and it will just move all of them over from synthetic shadow to native shadow in one fell swoop. One thing to be aware of about how native Shadow DOM works is that when you have a Shadow DOM component, any child components inside of it, and any child components inside of those components, and so on and so forth, they all get forced into native Shadow DOM mode, regardless of what that component actually put as its shadow support mode. So in this case, this native C native component is the container, which is native shadow. Inside of it, it has this child component. The child component is going to be forced into native shadow mode regardless of what is inside of that child component. So this is just something good to be aware of. It's something that is that was built in because of the way that synthetic Shadow DOM works. It just turns out that synthetic Shadow DOM does not work inside of native shadow components. So this was just a fundamental constraint of the framework that we had to put in effectively. And what do you get when you move to native Shadow DOM? Well, one example, which I kind of mentioned before, is this new CSS : part syntax. So you can use this to style child components. In this example, I've got a child component that has declared a part attribute of custom div. And then what that allows a container to do, a parent to do, is then to style that div by using the : part syntax targeting that custom div. And you can put whatever you want in there in that custom part name. But this is only available in native Shadow DOM. Now, I do have to mention that native Shadow DOM has some limitations currently. The biggest one is one I kind of alluded to earlier, which is that CSS does not leak into components. What that means is that as components are authored today, things like SLDS classes are not supported. Instead, you would have to use styling hooks, which styling hooks work across synthetic shadow and native shadow. The class syntax does not because of the way that CSS is encapsulated in native Shadow DOM. Additionally, not all base components today support native Shadow DOM. So that issue I mentioned where you have a child component and it's forced into native Shadow DOM mode, today that will not work if you are using a base component. And so my recommendation would be that if you want to use native Shadow DOM, it's best to do it when you own the entire component tree. So this is for folks who are building all of their components from scratch. They own the entire component tree. That is a great candidate for using native Shadow DOM.
And just to add, that is something that will change over time. So this is kind of our first version we're putting out there, and over time we expect more support for platform components.
Yes, and stay tuned to those announcements as support for individual components rolls in release to release. Finally, there's some accessibility issues with native Shadow DOM versus synthetic Shadow DOM. ARIA references cannot cross shadow boundaries. If that sounds like just gibberish to you, that's OK. There is a full blog post that you can read to learn about all these details as you migrate your components from synthetic Shadow DOM to native Shadow DOM. And once again, this will be linked at the end of the slides.
All right, my turn. So I'm going to be talking about server-side rendering. I will be using SSR as an acronym for that because server-side rendering is something I will stumble over if I say it more than 5 times in a row. So I'm going to just start with what is SSR. And to kind of illustrate what SSR is, I'm going to start with CSR, client-side rendering. This is what you are doing today. So if you are developing LWCs today, you're in the left box today. Client-side rendering means your component code that you write is running inside a browser window. And it's instantiated there. It interacts with the DOM there. It displays UI to your end user there. Everything's there in the browser. In contrast, with server-side rendering, it's more complicated. Initially, there is a server involved, and on that server, your component code may be running. And when it runs and renders, it's not interacting with the DOM because there is no DOM to interact with. You're on a server somewhere. Instead, you are rendering to HTML markup. So kind of what you would see in the dev tools maybe is roughly about what is being generated on the server in this markup rendering. And What happens is your component renders to markup on the server, and it's sent down with the response when your end user navigates to a page. And then that shows up on the page before any JavaScript is even running. There are some benefits here. There are performance benefits. So your end users are seeing content faster. You don't have to wait for all the JavaScript to run and all the data to be fetched before something's shown on the screen. So that's a plus. It's also easier for search engines to index your site. So if you're working on something public-facing that you want Google to be able to find when somebody types in a related search query, then this sets you up to be more indexable and accessible from a search engine. So there are some benefits to doing this that are well documented, but it is inherently more complex. So I would also add development is trickier. And I'm going to go into a little bit of why that is in the next few slides. But there's trade-offs here. Definitely, there are boons for your end users, but for you, the developer, there's more work involved. And we will be trying to smooth out the offering as much as possible. Before I move on, I meant to say this at the top of the slide. Server-side rendering is in a closed pilot. It is a limited pilot. It is not something that you can just go onboard onto yourself right now. It is part of a larger offering that I'm going to be talking about a little bit later and providing more information about. But just to be really clear, this is not like shipping today. And I'm going to clarify where it's shipping and what that might look for you. So I'm going to continue on. What would it mean for you to take an existing component that you've written and make it friendly to SSR, SSR friendly? What would that look like? Well, first of all, SSR does not support synthetic shadow DOM. Nolan was talking about that earlier. That was the partial polyfill for shadow DOM that we've supported on the platform for some time. And that isn't supported in SSR. There are some technical reasons for that I'm not going to go into. And so rather than synthetic shadow DOM, you're going to have to choose one of two options. You're going to either have to choose native shadow or light DOM. Second, and I'm going to talk about, these are kind of top-level bullets. I'm going to talk about these individually as well. So I'm going to just continue on here. The second thing you'd have to do is add the SSR capability to your JS meta XML file. It's pretty simple. So that one's going to be a gimme. And then the third one, you're going to have to potentially make changes to your component code. Because you're not running in a browser, things you do in a browser may not be possible when you're rendering in this server environment. So I'm going to cover that too and give you some tools for setting yourself up for success there. OK, so the two options I was talking about, either native shadow DOM or light DOM. Native shadow DOM, Nolan has spoken about already. You can use the LWC code mod tool to kind of prep your components and onboard to this native shadow mode. Similarly, if you want to use light DOM, there is a transform you can use with the LWC code mod tool called shadow to light. And that will add the render mode light static property to your JavaScript. And it will add the LWC render mode light attribute directive to your top-level template component, or template tag, excuse me. Light DOM itself, probably easiest to understand light DOM as just getting rid of shadow roots altogether. It's very similar to like how React, the web framework React would render, or a number of other web frameworks that are out there and available for JavaScript development. So you don't have shadow roots, and these are the two options that we support in SSR.
And one thing I would add to that is that the shadow to light transformation for LWC code mod actually does quite a bit of work to try to smooth over some differences between shadow DOM mode and light DOM mode. So it smooths over things like the fact that you need to do this .query selector instead of this .template.query selector, although you should be using refs instead, as we talked about. It smooths over differences in how slot change events work. It changes your CSS into scoped mode. So it's a really neat tool if you choose to use light DOM.
All right. This was the easy part, so this won't take super long. This is your JS meta XML file. All you really need to do to support SSR, if you are in the pilot, so just again reiterating, you have to be part of the pilot for this to actually do anything, you would add this capability. The one at the top says server renderable with hydration. The one at the bottom is server renderable. Kind of the important distinction here is, I'll talk about the one on the bottom, just server renderable. Imagine you have a footer component. It's at the bottom of your page. It includes the copyright statement. That thing renders once. It never changes. You can't click it. Nothing happens. And that is perfectly fine to render once on the server as HTML markup and show up on the page, and then no JavaScript is involved from that point. That's the second capability you have. The one at the top with hydration means the markup is generated on the server, it shows up in the browser, the content is displayed, and then JavaScript is run and attaches your LWC Lightning Element class to the DOM structure that originated from the server. And you'd want that if there are buttons that need to be clicked, if the content needs to update, if you're responding to events that might be happening globally in the window context, something like that. So basically, like, if you want, after that first time it renders, for something different to happen later, you're going to want that with hydration capability. All right, so third, to support SSR, you will have to, in many cases, make changes to your component code. There are a lot of potential issues, so I'm just going to talk about one right here. Imagine that if statement wasn't part of it, and just the window.add event listener. Window.add event listener resize. And what this does is you can have a callback, and when the user resizes their browser window, you do something. And maybe that means you resize something yourself. Maybe you stop displaying it, some element when the window gets narrow enough. Could be a lot of different things. Running window.add event listener on a server somewhere makes zero sense. There's nobody sitting in a server room somewhere clicking buttons and generating events that the code is going to respond to, right? It's all static. It's all happening in the cloud, and you're just going to get sort of an initial response in that context. So window doesn't even exist in the server. Window.add event listener doesn't really have a meaning on the server. And so if you try to run this on the server, it won't do what you want. And in some cases, depending on how we have things set up, it might just actually throw an error, because clearly you're trying to do something that isn't possible. And so we have this flag called import meta env SSR. And this flag is a little bit lengthy. I won't go into why. It's either going to be true or false. Just think of it, this is a true or false thing. If your code is running on the server, this is true. If it's running in the browser, it's false. So in this case, we're saying if we're not running on the server, in other words, if we're running in the browser, then you can do this adding event listener thing. There are a lot of nuances to this. Like, I imagine that thinking about code that you write as an LWC author running outside the browser is sort of a foreign concept. So what we are trying to do is put together as many tools as possible to help you succeed in doing that. So one of those things is lint preset. You can see it there on the top of the top bullet, Salesforce ESLint config LWC. If you've used the SFDX tooling and you have that style of project, you already have linting enabled in your project. And all you would need to do is add that one line at the very bottom there that has the big arrow pointing at it, the /SSR preset. And if you do that, all of a sudden you're going to see yellow squigglies and red squigglies in your editor. When you try to build, different things will happen. And you'll be warned, you're trying to do something in your component, you're intending it for it to run on the server somewhere, and these two things are incompatible. And so it's going to be pointing those things out to you proactively so that you don't have to just have a perfect mental model of all the differences. If you don't have linting in your project, we have a link at the end included with all the others to help you kind of understand what the linting looks like with SFDX tooling, how to add it, and so on. All right, so this is where I'm going to just hammer home, still experimental, still a pilot, rolling out to limited pilot customers now. The reason we're bringing it up now is it may have an impact on how you want to be writing your LWCs moving forward. This is a new platform with new capabilities that provide performance and SEO benefits. And so, somebody's going to come to you at some point and say, hey, I really think we should use this platform because it's good for our business. And you will need to know what that means for how you write your code. So that's why we're bringing it up right now. Second really important point, we're not going to break your components. We're saying this over and over. If your component is running in Lightning Experience today, it'll continue working exactly the same. The introduction of these new technologies and offerings will not impact that. It's something you would have to opt into explicitly. Let's see. I think that's about it for SSR. This is kind of still early pilot, so we're rolling things out. We're polishing things as we go. We're trying to provide a good developer experience. If you have feedback, we want to hear it. And we'll be sharing more as the pilot progresses. This is also a great talk that was given at the last Dreamforce, I think. That's what it says on the slide, so I'm going to assume I'm right there. This was given at the last Dreamforce. This goes into considerable depth, talking about the new platform, basically this offering where you would want to be opting into SSR. All right, this is a big QR code. We have said at the end of our talk, you will see a QR code with lots of links. This is the one that you want to capture. If you have questions, or if we said, hey, we have a resource, and somehow between the two of us we forgot to include it in that list of links, just drop a comment in that same place, and we'll respond with the resource that's missing. That's also a good place to just reach out and initiate contact if you want to have conversations after this. That was all we had. 2 minutes to spare. Yeah. Thank you.